Okay, so we conceptualized the concept of work, and we also understood the formula of work, and we analyzed that particular formula, and we got the conclusion that this is work done is force into displacement in the direction of force, okay, or done in the direction of force. And we said unit is Newton meter, or we say Joule, or Joule we can represent it by capital J. Okay, so this is the representation of unit, the representation of work. Okay, now we will define the concept of 1 Joule. What is basically 1 Joule? Now we know that work is basically what? Work is the combination of force and displacement. This is general definition. So if I say 1 Joule, so I can write 1 Joule as 1 Newton meter. I can write it as 1 Joule means 1 Newton meter. Now what is 1 Newton meter? It represents that when on a surface, when a block is pushed or pulled by a force of 1 Newton, okay. So what I am doing is, on a surface I kept a block and I applied a force of 1 Newton on this block. Either I can push it or I can pull it. In both the cases force will have that direction, okay. So force of 1 Newton is applied to this block, and due to this force, if the block moved by a distance of due to this 1 Newton force, if the block moved by a distance of 1 meter, we say in this case that work done is known as force into displacement, where force is 1 Newtons and displacement is 1 meters. So this will give you 1 into 1, that is, or I can write directly as 1 Newton meter, or this can be written as 1 Joule. So what is 1 Joule? 1 Joule is the work done by a 1 Newton force to displace a block by 1 meter. That is, to change the position or to move this block by 1 meter. So 1 Joule can be defined as, it is the amount of work done by a 1 Newton force to move a block by 1 meter. Okay, so 1 Joule is defined as the work done that by this force, by this 1 Newton force to move this block by 1 Newton. Okay, and this is known as 1 Newton meter or 1 Joule. This is the definition of work done. Now if I say what is the negative 1 Joule, if I say if work done is minus 1 Joule, so what does this mean? If the work done is minus 1 Joule, it means that the displacement is opposite to the direction of force. Now how can it happen? It can happen if I have a situation in which this is a block and this block is moved by 1 meter to this position, okay. If this block is moved by 1 meter to this position, and the force of friction, the force that friction is applying is in this direction, okay. The friction will always be in this direction, and let's say the friction applied is 1 Newton, okay. So what we can say, if the friction is 1 Newton and the block moved by or moves by 1 meter, then work done would be equals to, the friction is 1 Newton, so it will remain 1 into displacement is minus 1, that is this will give you -1 Newton meter or -1 Joule. Okay, because in this case force is in this direction but the displacement is in this direction. That's why we will say the work done becomes -1 Joule. So if you try to write the definition of -1 Joule, you can simply say it is the amount of work done by the force which is acting opposite to the direction of motion, and the block moves 1 meter in the opposite direction of the force. Okay, so this is how we can define the 1 Joule. So this is just an example to let you know or it will make you feel that what exactly the work done is and how to calculate the work done. So this completes our discussion on the concept of work. Now we will solve some numerical problems and then we will continue with the new concept of energy. Okay, so you can note this. Okay, so till now we have discussed the concept of work and we discussed the formula for work, and we also understood how to use that particular formula in different cases. We discussed 3 different cases. Now based on this concept, let us solve some practice questions, okay, from the practice sheet. So we will solve the first question. The first question says, Rahul pushes a book by applying a force of 40 newtons. Find the work done by this force if the book is displaced by 25 centimeter along the path. Okay, so question says that there is a person, this is question 1, there is a person Rahul, he pushes a book by applying a force of 40 newtons. Okay, so the force applied by the Rahul is 40 newtons, and due to this force, okay, due to this force the book has moved by 25 centimeters. Now the displacement of the book is 25 centimeters. Our task is to calculate the work done by this force. Now we know the formula for work done is force into displacement, so I cannot directly write that it is 40 into 25. Why I cannot write 40 into 25? It's because 25 is in the centimeters. Okay, the unit of 25, that is unit of displacement, is 25 centimeters. But we have seen that force we generally the displacement that we take is the SI unit of displacement, that is the meters. So first we have to convert this 25 centimeter to meter. So it will become 0.25 meters. Now instead of 25 I can write displacement as 0.25 meter. So just multiply this, 4 into 25 will give you 1 and this will give you 10 joules. Okay, the unit of force will become 10 joules, or you can write it as 10 Newton meter. Both are same, no problem, you can use any of the unit. Okay, so this completes the question number 1. Okay, let's see the question number 2. A ball of mass 1 kg thrown upwards reaches a maximum height of 4 meter. Calculate work done by force of gravity during the vertical displacement. Now it says that you throw a ball upwards, okay, and we have to calculate how much work is done by the force of gravity. So when you throw a ball upwards in upward direction, you can see the gravity, the force of gravity always apply in the downward direction. So in question number 2, for example, this is the surface and you throw a ball upwards. Okay, the ball is thrown upwards and it reaches a maximum height of 4 meters. This ball reaches a maximum height of 4 meters. Okay, this much. We need to calculate the force of gravity, the work done by force of gravity during this displacement. So it displaces vertically, and if I talk about the force, the direction of the force is in the downward direction, because the force of gravity is always in downward direction. It is in downward direction. Now what is the force? What is the formula for force due to gravity? If the mass of this ball is m, then force due to gravity becomes m into g, where g is what? It is acceleration due to gravity. Its value is given in the question as 10 meters per second square. So in this case I will say force is equals to mass into gravity, and force mass of the ball is 1 kg into gravity is 10, acceleration due to gravity, so in 10 meters per second. So this will give you force as 10 newtons. Okay, so the force applied by the gravity on this ball is 10 newtons. And what is the displacement? Displacement is 4 meters. But what you can see is the ball is moving upwards. Okay, the ball is moving upwards, that is the direction of displacement is this one. But the force that the gravity applies is downwards. So is the displacement in the direction of force? No. It is exactly opposite to the direction of force, and that's why I will put a negative sign in front of displacement, and now we can calculate work done as force into displacement. This will give you 10 into minus 4, that is minus 40 joules. Okay, so the work done in this case will become minus 40 joules. So this completes the second question. Okay, let's move to the third one. Question number 3 says, find the amount of work done by a man who carries n bricks of mkg each to the roof of a house h meters high by climbing a ladder. Okay, it says that, question number 3, it says that there is a man who carries n bricks of mkg each. N bricks of mkg each, that is each brick is m kgs. Okay, and there are n number of such bricks. So the total mass of bricks is will become n into m kgs. This is the total mass of bricks. Okay, it's just like 5 bricks of 10 kg each, so total mass will become 5 into 10. So we multiplied both the things. Now this man carries this n into m kg block or n m kg of mass to a height of h by climbing a ladder. Okay, so definitely he is climbing a ladder. There is a force due to gravity, and there is a force that the man has to apply against the gravity. Now the force that the gravity applies is force by gravity. Force by gravity will become n into m into g, that is mass into acceleration. Okay, that is force is what? It is mass into acceleration. You know this by the Newton's second law. So force is equals to mass into acceleration. So this is mass and this is acceleration. Now to maintain the block, to keep holding the block, the laborer, the man has to apply equivalent force, that is force due to gravity. For example, this is a chalk, or let's say this is a 10 kg block. Now to keep it in my hand, to hold it in my hand, how much force I have to apply? I have to apply the force equal to the force of gravity. Okay, because if the force of gravity is more compared to the force applied by me, this will go down. If I apply a force more than the gravity, this will go up. Okay, so I have to apply a force which can balance the gravity. Okay, or to keep it holding my to keep this in my hand. Okay, to hold it properly, to hold it such that there is no motion in the block like this. Okay, so the laborer, the man, has to apply an equivalent force to maintain the negative force of gravity. Okay, so man has to apply a force in the upward direction, and the gravity is applying a force in the downward direction. Okay, so the force that this the gravity applied is in downward direction, and the force applied by man, force applied or force by man will be equals to N into M into G. That is the same force, but this will be in upward direction. Okay. Now imagine the situation, this is the ground, this is the ladder. Okay. So man has to climb the height of h. Okay, man has to move a height of h. Now the man is applying the force on the bricks in upward direction to hold it in his hand. Okay, and also he is taking bricks in the upward direction, that is to move it h height above. Okay, to climb this ladder he is moving in upward direction. So here we will say that this is the direction of force and the same is the direction of displacement also. Now by how much displacement, by how much distance the man is traveling to keep this bricks? He has to travel h meters to keep the brick at the roof of this house. Okay, and how much force he is applying? He is applying the force N into M into G. So the distance travelled or the displacement required is h meters. Okay, so by using the formula for work done is equals to force into displacement, we can see both are in the same direction. So force is N into M into G and displacement is h. So this will become N M G H joules or Newton meter. Okay, remember what we calculated is that is the force applied by the man. Okay, man is applying a force in upward direction and also moving upwards. If the question is that calculate the force or calculate the work done applied by or calculate the work done by gravity, in that case our work done would have become negative of M N M G H. Okay, the reason, if I have to calculate the work done by gravity, gravity is in downward direction but the bricks are moving upward because the man is carrying the bricks. So to move the bricks upward, that is in the opposite direction to the direction of force, we will going to have the work done as minus of negative of N M G H joules or Newton meter. Okay, so this is the solution for question number 3. Okay, let's now solve question number 4. An engine pulls a train 1 kilometer over a level track. Calculate the work done by the train given that the frictional resistance is 5 into 10 to the power 5 newtons. Okay, so the question says, question number 4, it says that an engine pulls a train over 1 kilometer. So there is a train, okay, or let's say there is an engine. Now this engine pulls the train, okay, train is behind it. Now it pulls the train by a distance of 1 kilometers. Okay, you need to calculate the work done by this train given that the frictional resistance. Now what is frictional resistance? It is the force applied by the friction to oppose the motion of train. Okay, that is the force applied by the friction to oppose the train. See, since this engine is trying to pull the train in this direction, okay, so the frictional force will try to oppose this motion and it will apply a force in this direction. Okay, in this direction we will going to have frictional force, and this frictional force that it is applied on this train is 5 into 10 to the power 5 newtons. This is the force applied by the frictional force. Now how much force this train or this engine has to apply to move this train by 1 kilometers? Definitely the train or the engine has to apply a force equivalent to this force, that is 5 into 10 to the power 5 newtons. The engine has to apply a force equivalent to this force to move the train 1 kilometer in the forward direction. Therefore the force applied by force required by engine would be 5 into 10 to the power 5 newtons. Okay, and now what is the displacement of this train? It is displacement S is 1 kilometers. Now it is 1 kilometer, we need to convert it into meter, so it will become 1000 meters. Okay, so what we can say that the force applied is 5 into 10 to the power 5 newtons and distance travelled or displacement is 1000 meters. So the work done by engine would be force into displacement, that is 5 into 10 to the power 5 newtons into 1000. So this will give you 5 into 10 to the power 5 into and 3, so it will give you 8. This is newtons meter, or we can say joules. Okay, let me write it like this. Either it is 5 into 10 to the power 8 newton meter, or let me write it here only, or 5 into 10 to the power 8 joules. Okay, now this would be a positive force, positive work done. Reason is the train that is applying the force is in this direction and the displacement is also in this direction. If the question is that to calculate the work done by the friction, in that case our answer would be negative of this answer. Reason? Because friction is in that direction and the displacement is in this direction. Okay, but right now the answer is 5 into 10 to the power 8 newton meter or joule. So this completes the fourth question. Now let's move to the fifth one. A man weighing 70 kg carries a weight of 10 kg on the top of a tower 100 meter high. So a man is trying to carry 10 kg of weight and the man itself is 70 kgs. So he is trying to carry the weight on a tower which is 100 meter high. Okay, we need to calculate the work done by man, and the acceleration due to gravity is given as 10 meters per second square. So the question says that, for example, this is a tower and the man is trying to, this is the man and he is trying to climb this tower. Okay, and he is carrying a load of 10 kgs with him. This is the man which is of 70 kg and this is the load which is of 10 kg. So in total the man has to carry how much work, how much mass? The man has to carry total 10 plus 70, that is 80 kgs of mass, because obviously he need to carry himself also, he need to carry his mass also. So work done that he need to do is, he needs to apply, he needs to do the work on this mass as well, on his own mass as well. So now he is trying to climb this. Now we need to calculate the work done by man. Okay, now if I ask you what is the force applied by the man, so the man will apply a force such as to maintain, such as to nullify the effect of gravity. Okay, now how much force the gravity is applying on this man? If this is the man and his load, that is 80 kg, the gravity is applying a force in downward direction. Okay, and force due to gravity will be mass into acceleration due to gravity, that is 80 into 10, that is 800 newtons. Okay, gravity, acceleration due to gravity is given as 10 meters per second square. So you are given with this data and this is the force applied by the gravity. Now man has to nullify this force, man has to counter this force. So the force applied by man would be same 800 newtons, but the direction would be this one. This is the force applied by man, this is the force applied by gravity. Now the man is climbing this 100 meter tower, so man will move in this direction. Okay, so the displacement of man will take place in this direction. So S would be 100 meters and it will be in the direction of the force that man applies. Okay, so the work done by man will be, work done by man would be force into displacement, that is 100. This will give you 8 into 10 to the power 4 joules. Okay, if the question is such that to calculate the what we can say the work done by gravitational force, in that case we would have a negative answer, that is minus 8 into 10 to the power 4 joules. In that case, that would be our answer. Okay, but right now we need to calculate the work done by man. So this would be 8 into 10 to the power 4 joules. Okay, that is positive value. Now, so this completes question number 5. Let's move to the 6th question. A coolie carries a load of 50 kg on his head and walks on a level road up to 100 meters. What is work done by him? So question says that there is a coolie who carries a load of 50 kg on his head and walks on a level road up to 100 meters. Okay. So let's try to sketch the situation. On a level road, there is a coolie, okay, and he is carrying a load on his head. Okay, so this is a coolie, and coolie is carrying 50 kgs on his head, and coolie is trying to move in this direction, and he moved 100 meters on this horizontal road. So we need to calculate what is the work done by this man. You can see the man is carrying 50 kg, so you might think that 50 into 100, 50 into 10 into 100 would be the answer, but please think it carefully. This is 50 kg which is kept on the head of the man, and to balance this weight on his head, he need to apply a force against the gravity. Now gravitational force, that is the force applied by earth, is in the downward direction. We can say this is a force of gravity, and to balance this force, to counter this force, in which direction the man has to apply force? Obviously in this direction. That is the force applied by man is Fm, that is above, that is opposite to the force of gravity. So you can see the direction of force is this one, and the man is traveling in this direction, displacement. So we can see that force and displacement are perpendicular to each other. We can see force applied by man is perpendicular to his displacement. And what happens when force and displacement are perpendicular? Does the man is moving in upward direction, or is he moving in the downward direction? No, he is moving straight. So we can say force and displacement are perpendicular, and this is the case 3 that we have discussed regarding the formula when we analyze the formula of work. And in that case, work done by man would be 0, and the reason is very simple. Force applied by man and displacement are perpendicular. They both are perpendicular to each other. That's why the situation arises when man does not, when the man has not done any work. Okay. So what we can see is, although the man or this coolie is carrying a load of 50 kg on his head and is moving on a straight road, but still he is not doing any work. Okay, you might feel that to carry a 50 kg load, it uses a lot of energy, and definitely there has to be some work, because actually he is doing some work, but in scientific terms he is actually not doing anything. Okay, he is not actually doing anything. His work done is 0 joules. Okay, let me put the unit as well, 0 joules. So a very interesting question, 6th one. Okay, so this completes the practice question, and this completes the concept of work. Now we will discuss the concept of energy, and we will discuss various types of energy, that is kinetic energy, potential energy, and then we will understand a very important law in work and energy, that is the law of conservation of energy, which says that energy can never be created or cannot be destroyed. It can only be transferred from one form to another form. Okay, so you can note these 3 questions, and then we will continue.